Whether it's your lucky brain, vegan dog food, or why humans are the only talking apes, New Scientist explores the biggest questions surrounding the most fascinating topics. Get instant, unrestricted access to all articles when you treat yourself to our 12 weeks introductory offer and save 83%. And if you're in the US, you get 6 weeks free access. Go to newscientist.com/autumn special to sign up. Hello, welcome to New Scientist Weekly. This is the show that brings you a curated selection of the essential stories of the week. Now, our aim is to feed your curiosity. I'm your host, Rowan Hooper, in London.
And I'm Chelsea White in Portland, Oregon. Welcome to the show.
Hello, and this week we're also in New York City for Climate Week. It's the biggest climate event on Earth. James Dineen, we've got you there. How is it?
It's busy. Climate Week is happening alongside the United Nations General Assembly, which just got going on Monday, and there's all kinds of summits and forums underway, so it's a good week to catch a panel or two.
Cool. Right, we'll hear about that soon. We're also joined in London by Alexandra Thompson and from Spain by Alex Wilkins. Hello, both.
Hello.
Right, before we start, we have to give a big shout out for New Scientist Live. It's the world's greatest science and technology show. It's in London from the 7th to the 9th of October, and the early bird offer for tickets closes on the 25th of September. So go to newscientist.com/live to book your tickets.
Coming up on the show this week, we're going to hear about a rocket that's about to smash into an asteroid as part of our planetary defense testing. And we've got a number of reports that cases of early puberty in girls have increased during the pandemic. We're going to talk about that.
Yeah, and talking of planetary defense, there's something really funny that I've got to play for you at the end of the show. So do listen out for that. We've also got news from Enceladus, Saturn's moon, that it's got one of the building blocks of life has been detected on it. And we've got an estimate, just as a total gear change here, an estimate of the number of ants in the world. But we're going to start with Climate Week because, as James said, there's a load of stuff going on, and we'll put a link in the show notes if you want to check it out. It's climateweeknyc.org. But James, take it away.
Yeah, there are hundreds of events happening all over the city this week trying to rally businesses and governments and people of all kinds to take action on climate. Many of these events are streamable for free online for those not in New York who might be interested. The theme of this year's Climate Week is Get It Done, it being slashing
Short and
greenhouse
sweet,
gas. Yes, yeah.
Get it done already.
Get it done. It being slashing greenhouse gas emissions across countries and sectors to prevent as much warming as possible. And the array of events makes clear all the places this can happen, from dealing with emissions from agriculture and the oil and gas industry to retrofitting buildings and adopting electric vehicles to protecting and restoring forests from the Amazon to the boreal forests of the north. And as part of that, today, I'm going to the Global Maritime Forum in Brooklyn, where the shipping industry is set to meet to talk about how to reduce emissions from shipping stuff all over the world, which are substantial.
Yeah, that's an understatement, isn't it?
Yeah, the global shipping industry is responsible for about 3% of total global greenhouse gas emissions, which is about the same as Japan or the aviation industry. There are more than 100,000 large ships steaming around the ocean today, and that number is only expected to grow, which could mean more emissions depending on how those ships are propelled.
Yeah, shipping doesn't get talked about enough, does it, when we think about how to get to net zero? So we have to obviously get rid of those fossil fuel powered ships.
Pretty much. The dominant fuel powering many of those ships is a tar-like oil called bunker fuel. Many ships also run on diesel and nitrogen gas. And reducing emissions from shipping can happen through energy efficiency measures like slowing down ships, but fully decarbonizing global shipping ultimately will mean replacing those high emission fuels to propel ships in some other way.
And are they meeting to kind of agree on a plan to do this?
This meeting isn't to agree on a plan. It's sort of like a forum to come together to talk about what the industry is doing, how far they've made, and how much progress they've made. And the industry's central strategy to doing this so far has been to replace those high emissions fuels with fuels that don't emit huge amounts of greenhouse gases, such as green hydrogen or ammonia or a biofuel called methanol. And there's a new report which they're releasing at this forum today that takes a look at progress so far and finds that things are only, quote, partially on track towards their initial goalpost of using zero emission fuel for 5% of shipping fuel by 2030.
Right. Okay. So the goal is for 5% of shipping to be zero emissions, which doesn't sound like much of a strenuous goal.
Yeah. So 5% of shipping fuel being zero emissions fuel by 2030. It sounds small, but the authors of the report at least see it as a breakthrough point needed to put the infrastructure in place necessary to rapidly scale up use of zero emission fuels after that point. And they estimate in this report that cutting all shipping emissions by 2050 would require more than $1 trillion of investment in green shipping, most of that to be spent on infrastructure that's required to make, transport, store, and use zero emissions fuel. So it's a long voyage ahead.
Well done.
Thank you. And the reason things are only partially on track so far is because this is an old story, but pledges and commitments and declarations haven't translated to sufficient action. But commitments do represent some degree of progress, and 14 countries, including the UK and the US, have signed a declaration to decarbonize shipping by 2050. And the International Maritime Organization, which is the United Nations body that regulates international shipping, has adopted plans to reduce shipping emissions 50% by 2050.
Well, that's good to hear. Is there any more hope to leave us with? There
are also more than 200 green shipping pilot and demonstration projects that are currently underway or have happened. One of the largest shipping companies, Maersk, has ordered 8 huge ships that can burn methanol instead of oil-based fuel. And I think this one's interesting. 22 countries have committed to create 6 zero emissions shipping routes by 2025, including a route between Shanghai and Los Angeles. And those routes could help create the initial infrastructure needed to scale up green shipping from that point.
Alex, you're at Europlanet Science Congress in Grenada. There's loads of cool stuff going on, but let's start with NASA's DART mission, which is the Double Asteroid Redirection Test, right?
Yeah, so it's a pretty interesting mission. It's going to be the first ever real-world planetary defense mission. On Monday, there's a satellite, weighs about 500 kilograms, and it's going to smash into a 160 meter wide asteroid called Dimorphos, which is itself orbiting a bigger asteroid called Didymos, and it's going to try and change the orbit of this small orbiting asteroid.
I take it these asteroids are like, what, are they in the asteroid belt? Are they far away from us?
Hopefully.
Yeah, there's no chance of these asteroids hitting Earth. They're millions of kilometers away and present no real threat, but they'll be a really useful testbed if we ever need to divert an asteroid for real.
So the plan for Monday, the idea is to use the momentum from the satellite to divert it, right? We're not trying to blow up the asteroid.
No, it's quite a subtle hit, really. They're going to fly the satellite in the opposite direction to Dimorphos' travel, and it's going to be traveling around 6.6 kilometers a second, or that works out about 24,000 kilometers per hour, to slow it down ever so slightly. And when it slows down, it will reduce its orbit slightly and sort of bring it closer in to its parent asteroid. There's also another satellite alongside DART called Lycia Cube, and that's going to take pictures and survey the aftermath of the impact. So hopefully we should get some really good images of the asteroid post-impact sometime early next week.
And so the idea then is if we had a real emergency, you'd be able to spot something early on coming towards Earth and launch something. And then if you hit the asteroid early enough, you'd be able to shift its trajectory just a tiny amount, but that would be enough to dodge us.
Yeah, exactly. And that initial bump really doesn't have to be massive. Over the sort of millions of miles until it reaches us, that first impact could turn into a really massive deflection if we manage to identify it early enough, and it would steer it wide of Earth. It's a bit like a bowling alley. When you first let the ball go, you can't exactly tell where it's going to arrive at the pins, but by the time it sort of goes down and gets to the end of the lane, that position has become pretty clear and you know exactly which pin it's going to knock over.
Yeah. or it's me not, if you're going to like completely
Yeah.
miss all of the pins. But like, people talk about asteroid strikes a lot, don't they? Like long-termists have that on their list of things to worry about for the future. I know that NASA are tracking loads of near-Earth objects, aren't they? Do we know like what the likelihood is of a dinosaur level event?
Yeah, so as you said, NASA, through its Jet Propulsion Lab, has a program called Sentry, and this tracks or attempts to track all of the asteroids near Earth that might cause significant damage. And it actually keeps a risk table of the sort of biggest threats. And the highest risk object on there right now has a 2.5% chance of hitting Earth in 2082, and it's only about 2 meters wide, so not too scary. Having said that, there are some estimates that we only know around 40% of all the near-Earth asteroids around us that are more than 140 meters across. So if we do find something, and there's definitely a chance in that 60% of asteroids, then we really might need something like DART.
Let's take a quick break to hear about a new project from our sponsor, Dow. Now, what happens to the plastic you throw away? The truth is that just 14% is recycled, with the rest incinerated or sent to landfill. Now, current recycling also lowers the quality of plastic, and that limits its use. So this is all set to change now thanks to an innovative recycling technology that turns plastic waste into a feedstock for the virgin material that's just as good as the original. So the result is you get this circular manufacturing process that should dramatically lower the carbon footprint of plastics manufacture. And you can find out more about this plastics revolution at newscientist.com/Dow.
And we must also give you a final reminder that our early bird offer for New Scientist Live closes this Sunday, the 25th of September. It's your last chance to get discount tickets to the world's greatest festival of science and technology. Go to newscientist.com/live to get those tickets. It's time for Lifeform of the Week. Rowan, do you want to hear about some ants?
I always want to hear about ants, yes.
Well, what I have to tell you is either amazing or horrifying, depending on your opinion of ants. But either way, I think it's pretty mind-blowing. A new study has estimated that there are 20 quadrillion ants on the planet. That's 16 zeros for those who are counting.
16 zeros is 20 million billion ants.
Yeah, that's right. Think of all the legs and all the antenna.
Lovely. Yes, crawling all over us, all over the planet. So what? Have they sort of totted up the weight of all of them, the biomass of that?
Yeah, they have. It's 12 million tons, which is more than all the birds and mammals combined. And humans make up about 60 million tons, so they don't outweigh us, not yet.
And how did we get to this estimate of 20 quadrillion ants?
Well, before now, any estimates of, the number of ants on the planet were basically educated guesses. But a team of researchers has compiled data from almost 500 studies that measured ant density in different parts of the world, which sounds kind of like delightful work. And it could be an underestimate because there are still gaps in the scientific record, and many ant counts have been done on the ground, which misses out on ants that spend time in trees or mostly live underground.
I happen to be reading an amazing book it's called Ants and Their Guests at the moment. There's more than 15,000 species of ant. So yeah, it's not surprising that we haven't, catalogued the densities of them all. We don't even know all the species, let alone the population size of them.
Yeah, absolutely. When I saw this story, I got really curious about where ants live, like where they might be distributed on the planet, and where they don't live across the globe. And so I found out that the only places that don't have ants are Antarctica, Greenland, Iceland, and some, island nations.
Yeah, although all those places have ants now that have sort of transported over there, like rats get over there, but I get no native species in those places. Have you got a favourite ant, Chels?
I do. I've always been really delighted by desert ants, mostly because they do this really cool trick of navigation. And when they go out foraging, they leave their nest and they travel any which way, looking for food and whatever. And then when it's time to go, they spin around in a circle, a little 360 pirouette, and then they walk directly back to their nest in a straight line. And they use both the position of the sun in the sky and the polarization of light and some of them the Earth's magnetic fields to orient themselves and find the quickest path home across a landscape that just doesn't have very many landmarks.
Wow.
Yeah, I wish I had a little internal compass for tracking the sun like that. What about you? Do you have a favorite ant?
I do. I mean, this book I'm reading, I'll put a link to it because in the show notes because it's awesome. I've just been reading about weaver ants, and they build these like tents out of leaves in the canopy of trees, and they get their own larvae. Right, a worker ant takes the larva in its jaws and then works it like a shuttle on a loom and like sews up and like squeezes it gently, and it produces silk, and it
Oh,
sews up the leaves. Like it just uses its own larva to sew up the leaf, and it makes little, it makes these little canopies and pavilions for other ants and for the queen and the other brood animals to live in. But they also make them for their farm animals. They farm different kinds of animals
they're
like this.
farm animals?
Yeah,
What are they farming?
they farm these bugs, hemipteran bugs that produce honeydew, and caterpillars that also produce nectar from a special gland that the ants farm.
Incredible.
Yeah.
A whole little village of ants doing little work.
I actually want to make a podcast all about ants now.
Oh, let's do it.
Yeah. Okay, we're off to Enceladus, Saturn's lovely moon.
Yes, and the news from Enceladus is that phosphorus has been detected there. Alex, this is really cool and interesting. Yeah?
Yeah, no, it really is interesting. Phosphorus is the last missing building block for life that we just haven't found yet on Enceladus.
Although I'm slightly disappointed because when you said building block for life, I was thinking it's going to be one of the base pairs of DNA, but it's just phosphorus.
Just phosphorus.
Yeah, no, it doesn't sound that exciting, but actually it's really quite cool. Enceladus has loads of features that make it potentially habitable. It's got a liquid ocean. The ocean is a bit warmer. It's potentially got a warm core heating this ocean. And it has almost all the key elements that we found on Earth in every single life form. So it's got carbon, hydrogen, nitrogen, oxygen, and sulfur. But until now, it didn't have that last sixth key element, phosphorus. And that lack of phosphorus was really a problem. There were some researchers that thought it made life really unlikely to exist because that last sort of key building block was missing.
All right, I'll grant that is suddenly much more exciting. And what have they like physically found it, or is this from analysing the atmosphere and finding it there?
Yeah, so it's not exactly the atmosphere; it's a little bit further out. The spacecraft Cassini collected icy rock grains with an instrument called the Cosmic Dust Analyzer quite a long time ago, for a 13-year period from 1999, and it was all around Saturn's E-ring. This E-ring is mainly fed from an icy plume of sort of water ice that comes from Enceladus, and that in turn is fed from Enceladus's oceans. So it's sort of further out, but it all leads back to the oceans under Enceladus.
Right.
There were actually previous analyses of this material in 2009, but they failed to turn up any phosphorus at all. But that same research group have now reanalyzed these grains with more precision, and they've identified phosphorus molecules. I was in a talk yesterday with the lead researcher, and he said that Enceladus now satisfies what is generally considered one of the strictest requirements for habitability.
Wow.
It makes it sound quite attractive. If there's a travel guide to all the planets and moons, it gets a star next to its name, and like they're not going to change their minds again. Are we sure about that they have found phosphorus?
Yeah, the evidence seems pretty conclusive. I spoke to some people after the talk that were there, and they also said that their case seems pretty solid. This team analysed many more grains on an individual basis that hadn't been done before, and they also had these high-resolution spectra, which have been taken by other research groups in the decades since the first analysis of phosphorus that they could compare these grains to. Now, they looked at more than 1,000 grains, and they found 9 that, in their words, unmistakably showed the fingerprint of phosphorus. And this was in the form of various salts, a bit like table salt, with sodium and then other molecules like hydrogen and oxygen. And based on the levels that they found in these grains, they've even predicted that the ocean under Enceladus has levels of phosphorus between 100 to 1,000 times higher than what we find here on Earth.
So if it's 100 to 1,000 times higher than it is here on Earth, is that potentially habitable for Earth-like life, or would it be something else?
So we really don't know. We don't know how life evolves on other planets or other worlds. We don't know if these levels of phosphorus would actually be too high for life. And there are still so many question marks around what sort of form this life would take. I think most likely if it's in water, they're going to be very small, microscopic. But really, it's a huge open question right now as to whether life could form in these sort of alien environments.
And there is that NASA Orbilander mission. Has that got signed off? Does anyone know?
So I think it's still being debated. I think it's at the top of the list for missions in the next couple of decades. And as you say, it's probably our best bet. But the bad news is it hasn't even started being built yet. And even if it does get the final sign-off, the final go-ahead, it wouldn't launch until the late 2030s, and then it probably wouldn't get to Enceladus until the 2050s. So sadly, we can't really expect any more data anytime soon.
There are still loads of mysteries around COVID, and this week, Alexandra, you've edited a story suggesting that COVID may be triggering early puberty in some girls. It sounds a little concerning. What's going on?
Yeah, I agree. It does sound really concerning. So a growing number of studies are suggesting that girls specifically are going through puberty earlier amid the pandemic. So the latest in a string of studies comes from Germany, and admittedly it was just a single medical centre, but between 2015 and 2019, the number of girls being diagnosed there with this was pretty constant. It was fewer than 10 cases per year. But in 2020, when COVID-19 really took hold, that increased to 23 cases. And in 2021, it tripled to 30 cases. And unfortunately, it's not just in Germany. We're seeing this in the US, in Italy and Turkey. So it's not a one-off finding.
Yeah, it really does seem to be more than just a coincidence. So what exactly is early puberty?
Definitions vary according to the study, but generally speaking, in girls, it's when they develop breasts or start menstruating before the age of 8. And in boys, it might be developing a deeper voice or a more muscular frame before the age of 9. And I should point out, it's not only an increase in the number of girls experiencing this, but the age of onset is lower. So in the German study that I mentioned, the average age of the girls being diagnosed with this before the pandemic was 7.6, and during the pandemic it was 6.8. So it's almost a year reduction in the age of diagnosis.
Wow, that is really early. Do we have any idea whether it's the virus itself that might be, related to this, or if there's something about lockdown and general stress that came with the pandemic?
The short answer is we're not entirely sure, but the overwhelming consensus probably is the stress of the pandemic itself and lockdown, having to adjust to at-home schooling. There is also some evidence that sleep in children has been disturbed during the pandemic, and children are having later bedtimes. They may also be having more screen time because of the blessed relief of putting your child in front of the TV during lockdown. So it's probably a combination of those things, but ultimately it probably does come down to the stress of it all.
And age of puberty has been falling anyway, right, over the last decades, hasn't it? Not early puberty, but just like normal puberty.
Yeah, so since the late 1970s, it's fallen by 3 months on average per decade.
Wow, that's a lot. Is that because we have better nutrition now since the 70s?
I would say it's probably the opposite. It's more sedentary lifestyles and a decline in the quality of nutrition children are receiving, because we do know that if children are heavier, they're more likely to start puberty earlier. But in the context of COVID and the studies we've discussed, they actually didn't find that. So when they looked at children who were diagnosed pre-pandemic and post-pandemic, there wasn't a significant difference in weight. But pandemic aside, we do know that if children are heavier, if they're overweight or obese, they are more likely to start puberty early.
So what comes next with looking into this?
Well, most people are pretty optimistic things will settle down as children adapt to the pandemic, which is ongoing. They're back at school now, but ultimately time will tell.
And we should point out this is still rare, isn't it? That early puberty affects only 1 in 5,000 to 1 in 10,000 children pre-pandemic, and it's not like it's increased that much. But it is interesting that it's, yet another thing about the whole COVID, the virus, and the pandemic that's having unexpected consequences, especially on children.
Yeah, exactly. And it should also point out that in most cases, treatment isn't recommended. It's only if they're concerned that it will cause the child significant emotional distress, or they're concerned about health problems later on. So it is rare, and it does tend to be mild.
And that's it for this week, but don't go away quite yet, because I want to play us out with one more thing. But look, thanks James in New York, both Alexes, and thanks to you for listening. Remember, newscientist.com/live gets you the last chance for early bird tickets to New Scientist Live.
See you next week.
Yeah, and let's play you out with something. This relates to the story we had on the first planetary defense mission that we spoke about. So you might remember a few years ago that President Trump ordered the creation of a new branch of the US military, the Space Force, and they've just released their official song. And I actually thought this was a joke when I first heard it, but
so did I.
It's really not, I promise. Like, all branches of the military have their own songs, and this is the Space Force's song. It's called Semper Supra, which means always above, and it's got a very 1950s vibe. I was expecting something more sci-fi, but let's play out with it. But thanks for listening, and bye for now. See you next week.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.